Hi, in this video, we're going to introduce EtherChannel. So in spanning tree, as you know, when we have multiple links to prevent any kind of loops from happening, which obviously can bring down our network real quick, the spanning tree algorithm blocks any redundant paths. But what if we actually want to use those paths to take advantage of having multiple links between two switches? Well, Cisco's EtherChannel technology allows you to actually bundle these physical links, creating a single logical link. This can be either access ports or a trunk link. So it allows you to actually expand the link's capacity, the bandwidth between two switches without having to purchase new hardware or running new cables or whatever. If you've already got the cables, the switches are close enough together that you can run multiple cables, you can actually, in this case, bundle them up and increase your bandwidth. So EtherChannel allows you to have from 2 to 8 links. So for fast Ethernet, that would mean up to 800 megabits. For gigabit Ethernet, that would mean up to 8 gigabits. And for 10 gigabit links, that would mean up to 80 gigabits. Now, there's a little bit of a misconception here. This doesn't mean you get the total bandwidth of the sum of the links. And the load isn't always distributed evenly. We're going to talk about that in another video on EtherChannel load balancing. And that's what it really does. It balances the load between multiple links. There's also EtherChannel for layer 3. And this can be configured on your multi-layer switches. It depends on the model of the switch. A layer 3 EtherChannel would have a single IP address associated with multiple ports. And again, similar to a layer 2 EtherChannel, it creates those multiple physical ports as a single logical port. So the Cisco Catalyst, Cisco switches support 2 types of link aggregation. One is known as Port Aggregation Protocol, PAGP, and this is a Cisco proprietary protocol. And there's also Link Aggregation Control Protocol, which is an IEEE 802.3AD standard. In both cases, EtherChannel provides redundancy. So if one link fails, then not only are you using multiple links to take advantage of the multiple links between the two switches, but if one link fails, the traffic automatically is moved to another active link. And all of this is completely transparent to the end user. And by the way, what's the difference between PAGP and LACP? Not a lot of differences, not even in the configuration. However, there are a couple of features available in LACP that aren't available in PAGP, and there's maybe 1 or 2 the same with PAGP. So there's not a lot of differences. You may want to look at the different features to see what works best for you. Of course, with PAGP, you need all Cisco switches to do it. Both ends of the bundle need to be Cisco switches. So the key here in EtherChannel is consistency. Okay, so as far as the media goes, they have to both ends have to be, say, using fast Ethernet in this example. Same duplex. Full duplex. VLANs. All the ports within the bundle must be configured with the same VLAN if it's an access port, or same trunking encapsulation if in trunk mode, the 802.1Q. There used to be ISL also. And same native VLAN. and pass the same set of VLANs. So if you're doing VLAN filtering on the trunk, you need to make sure that you're passing the same VLANs on that trunk at both ends. So we need to have the same configuration on both ends of the bundle. That's really important. Okay, we'll be talking about EtherChannel some more in later videos.